So when we were looking at polynomial transformations, remember that we only looked at monomial functions. So those were the type m of x equals like x to some power of n, and that was all there was to it. You could have had, of course, the actual transformations would have had something like a times bx minus c to the power of n plus d. Those were transformations on the monomial function, which was x to the n. And that's the only way we could really understand function transformations in polynomials, because in the other form, really a transformation does not apply to that. It's very similar for rational functions. In fact, rational functions are like monomial functions when you're looking at function transformations, because here we're not looking at m to the power of n, where n is 0, 1, 2, 3, 4, 5. Here we're looking at when n can be -1, -2, -3, and so on. That's what a rational function really is, and that's kind of like a monomial, quote unquote, monomial rational function. And so they're going to look like this, where we have a over this plus d. Same, a, b, c, and d are all the same transformation thing. And that simplifies because a division by a power, you can rewrite that as a negative power here. So here n is 0, 1, 2, 3, 4, 5, 6, 7, 8. Well, 0 doesn't really make sense, but 1, 2, 3, 4, 5, 6, 7, 8, 9. And then when it goes up here, that's when this becomes positive. So I should actually say n is 1, 2, 3, and so on, because it's down here, and it becomes negative as a result. Now, when looking at this thing, we have the stereotypes of 1 over x, which is just x to the -1, and then 1 over x squared, which is the same thing as x to the -2. So most of the rational functions that you look at transformations of will always fit one of these two types. Just like in polynomials, right? We had x squared and x cubed. X squared was the parabola. It went up to the left and up to the right. X cubed was this shape here. It went down to the left and up to the right. Well, this is very similar in that regard, whereas any odd power is gonna somewhat be like this one, and any even power, or I should say negative even power, is going to be somewhat like this one. So you can see that we have here y equal to 0 is the horizontal asymptote, and x equal to 0 is the vertical asymptote. As we go up to the left, it goes to 0. As we go up to the right, it goes to 0. So we know the end behavior, right, is to 0 and 0. And we have this asymptote where it goes to the left. On the left-hand side, it goes to negative infinity. On the right-hand side, it goes to positive infinity. So this is the kind of behavior you would expect for a standard one. Of course, here we're going to be shifting them around up and down. So it may not be y equal to 0 and x equal to 0. It may be shifted left and up. So that means it's going to be some negative number here and some positive number here. And then, of course, the b and a, the multipliers will flatten it or stretch it, all that kind of stuff. For x equal to x to the power of -2, you can see it goes to 0 on the left and right hand side. But as it goes to this infinity here, or this asymptote here, it goes up on both sides. Of course, if it were negative, x to the -2 would be flipped downward, and all those things. Okay, let's look at the transformations of these rational functions, and then we're gonna graph them to show them what they look like. So here we know that c equals -2, right? It's always x minus c. C is -2, and d is +2. So the normal function, in this case, the standard function is 1 over x cubed, which is the same thing as x to the -3. That's going to be shifted to this says to the left by 2 units. And up by 2 units. So that's the transformations. Since this function has the same kind of shape as this one, right? The only issue in the domain was the asymptote here at 0. Well, that's been shifted to the left by 2 units. So it's not going to be at 0. It's going to be at 1, 2. So it cannot equal -2. Again, you can see that down here, right? -2 gives you 0 in the denominator. And the horizontal asymptote is going to be shifted up by 2 units, since the whole thing gets shifted up by 2 units. So the horizontal asymptote is going to be at y equal to 2. So the domain is -infinity to -2, -2 to infinity, and the range is going to be that, because the horizontal asymptote got shifted up. This one does not cross the horizontal asymptote, so we're not going to include that point here. Of course, the asymptotes themselves, the vertical asymptote, that's right here, is at x equal to -2, and the horizontal asymptote is at y equal to 2. That's from the range. All right, let's move on to the next one. We have a is -4, and we have c equal to +1. There's no d, and b is 1 as well. So we know that's going to be flipped. Since a is negative, it's going to be flipped vertically. The original function is 1 over x to the 6, which is the same thing as x to the -6. So the asymptotes, this is going to fit a lot like this function here, because we have a negative even power. And let's see, it's been shifted to the right 1 unit, so this vertical asymptote goes to here. Again, you can see that, right, when 1 minus 1 is 0, so we have 0 in the denominator there. So we have a vertical asymptote at x equal to 1. And then the horizontal asymptote would be at 0. It's been flipped, however, but that doesn't actually change anything. It still is at 0. So y equal to 0 is the horizontal asymptote. So that actually is going to be the same. So this thing's been flipped. So we know it's going to go down like that instead of going up and up here. The domain, I should say, it's what the transformations are, right? It's been flipped vertically. Since a is bigger than 1, well, if it were positive, it'd be bigger than 1. It's less than -1, so it's going to be stretched vertically. Then it's going to be shifted right 1 unit from this c equal to 1. Okay, the domain then is -infinity to 1. And the range, well, up here, right, the range was not negative. In fact, it wasn't even 0. It was, the range of this guy was 0 to infinity. And that's been flipped vertically. It's not been shifted at all. It's just been flipped. It's been stretched, but that doesn't change the range. So it's been flipped, so that means it's going to be from -infinity to 0. So you can, of course, sketch these things out. Let me actually move this over a little bit and just show you a quick sketch of what I would imagine it would be. So on the grid, we're going to have a vertical asymptote at -2, a horizontal asymptote at 2, It's not been flipped at all or stretched or anything like that. So it's going to be a lot the same as this one here, x to the negative 1. So I can expect it's going to be something like this. Goes off to the horizontal asymptote to the left and to the right, and off to the vertical one down and up. Similarly, for this one, we have a domain of 1. It's been shifted to the right 1 unit. Or I should say an issue in the domain of 1. And the range is now 0. We also have a horizontal asymptote at y equals to 0. That's just the x-axis. So we would expect it to look something like this. It's been stretched, so it's actually going to be a little bit thinner as well. But that's what I would expect for these, because they're going to look a lot the same as these ones here, but shifted or stretched or whatever. Okay, let's graph this on Desmos and see if I'm accurate. So R1 of x, that was this one here. You can see it's been shifted to the left and up. And we have y equal to 2 being the horizontal asymptote, x equal to negative 2 as the vertical one. And that was just about what my estimation was. That's what we expect. Now for the second one, you can see that we have x equal to positive 1 as the asymptote. It's been stretched, so it's a little bit thicker on there, but that's fine. And then y equal to 0 is the horizontal asymptote. It goes there pretty quick, or it gets close to there very, very fast, because we have x to the 6th power. So it means it's going to go to 0 faster than just x to the, negative 2 power. But that's what it looks like. Give it a try in number 4.